All right, hi guys, welcome to another online or video lecture. Today we are going to be talking about mineral identification. So we've talked a lot about how minerals form crystals, as you can see here, but that doesn't mean that all crystals are the same, and it doesn't mean they're all the same size, color, and there's going to be some other ways that we identify specific types of minerals. And so I'm going to go fast. Again, my goal is to try to always keep these somewhere in the 10-minute range. We'll see what we do today. So how do we identify minerals? Well, we look at the physical properties, right? And this is physical geology after all. So we are dealing with physical science here. These include color and appearance, something called luster, streak, hardness, and cleavage/fracture. So you can write those down. We're going to be going through them one by one. So you don't necessarily have to write them down now. So the physical properties of minerals, the first one we're going to talk about is color. So the first thing you're going to look at when you look at a mineral is its color. And we're actually going to be doing an engagement where we look at minerals and their colors, and along with these other physical properties. And that can help you a little bit, and it's going to definitely be the first thing you notice. But just so you know, it is the most obvious, but unfortunately it is the most misleading. So that might be something you write down. You don't need to write down all of this, just that color can tell us some about the difference between some minerals, but so many minerals have the same colors. So many minerals will have similar appearance, but will have different impurities. So a mineral, like I said, is generally the same chemical compound repeated over and over again, but minerals can have impurities in them. And some of you might be asking, well, would that make it a rock? Well, not necessarily, because the impurities might not be minerals themselves. So just know that color is not always the best indicator of what a mineral is, but it can help. So the next one is something called luster. So luster refers to the way a mineral reflects light from its surface. So this is different than color, because color is what light we actually like. There's a subtle difference, and it's kind of hard to explain, but basically color is what we're seeing. The light is the light that we're seeing being absorbed by the rock, whereas this is how it reflects light. So there's a couple different ways we describe luster. One is it metallic? So we break it into two categories, metallic and non-metallic. So you do need to write these down. Metallic, shiny like a metal. And then within non-metallic, there's a couple classifications. Dull, non-shiny surface, pearly, silky, and glassy. There's also terms such as waxy. So these are all terms, so you might want to write a couple of these terms down as well to help you when we identify our own minerals. So luster is not so much the color, but how it reflects the light, so keep that in mind. Streak. This is a really good one. So if you can kind of tell, we are kind of becoming detectives, and this is one of the cool parts about geology, because if you've ever seen like the Sherlock Holmes movies with Robert Downey Jr., he uses all these cool ways to figure out and solve the crimes. Well, we're trying to solve what our mineral is, and some minerals are really interesting in that they may look one color. This is why color is deceiving. So they may look one color, but the powdered form of the mineral is a different color. So you could have a mineral like you see over here, and let me change the color of my pen really quick. So over here, you have a mineral that looks dark but streaks gold, and then a mineral that looks gold but streaks more of the dark color. So this kind of just shows you, and you can even see some of those differences down here. So we use what is called a streak plate, white ceramic plate, and we're going to try to use those. I do have some that we'll try to use, but we'll see how it works out. The color of the streak can be different than the minerals, so that's what I had said before, so you might want to write that down. That's why streak can be a dead giveaway as to what mineral you're dealing with, because only certain minerals have a different color streak than what their actual color is. So that's a dead giveaway towards certain minerals.
But here's the deal. Minerals must be softer than the streak plate. And you might not know what that means, so we will talk about softness in a second. Here's just another picture of streak. So streak can help identify quartz. Quartz leaves a white streak no matter what color it is. So you have an amethyst, which is a type of quartz, and it will still streak white, as you can see on the right. So you might want to write that down, that quartz is a good one to identify with streak. So the scratch is actually what you're seeing here. So that's a scratch, is kind of how it manipulates the streak plate. So let's take a look at this now. Hardness. So we had mentioned earlier with streak that the mineral has to be softer than the streak plate. So what does that mean? Well, this has to do with hardness. So hardness is how easily a mineral scratches materials. Okay, and so if we go back really quick, I'll show you what I mean by scratches. So give me one second here. That might already be kind of known what a scratch looks like you've been scratched before. But just know that depending on the mineral type, some minerals will not be able to scratch others, while some minerals will scratch very easily. And you can see the hardness scale down below here. So number 1 is talc. That's like baby powder. That's where baby powder comes from, talcum powder, and it breaks up really easily, and that's why. So it's really easy to scratch talc. And it goes all the way up to diamond, which is the hardest known substance, and then anywhere in between. So you will actually use this scale and a couple different tools to figure out, the tools actually are right here, to see where the mineral is at with its hardness, and this can give us another overall picture of what the mineral is. So some minerals you'll be able to get right away, and some minerals you're going to have to use all of the tests to try to narrow it down. And one of those might be the hardness, and you'll have to use Mohs hardness scale. And I'll be giving you some of these tools. Cleavage and fracture are pretty interesting ones. So this is the way the mineral breaks. And we're not going to actually be breaking minerals, but you can tell all the minerals you get were broken from larger minerals. So you can actually see, so I always have to mention that because I don't want you breaking the minerals I give you. But some will break with cleavage, and cleavage usually leaves very small or very smooth lines with flat surfaces. Okay, fracture is when they break in a very random way. So you can see over here on the right, cleavage varies with mineral type. Mica breaks easily into distinct sheets. Halite breaks in 90-degree angles in 3 directions, and diamond breaks in 4 different directions. So these all still are examples of cleavage because they leave nice, smooth, flat surfaces. Fracture, you could imagine, leaves much more jagged edges. So it would be more like, it would look more like rigid, and kind of like a serrated knife, maybe, would be more of fracture. So if you can identify whether something has cleavage or fracture, that can also help narrow down what mineral it is. So I'm going to actually make this probably an Edpuzzle question here. But so which one of these has cleavage, do you think? Well, actually, it's asking for all of them. So number 1, what do you think that is? Number 2, what do you think that is? Go ahead and write it down in your notes. Number 3, 4, what do you think that is? All right, so let's take a look. So number 1 is very clearly what? This is cleavage, right? Very distinct, flat, smooth lines. This one's going to be, number 2 is a little bit more difficult because we have to ask, where did the mineral actually break? And it looks to me like the mineral broke at these edges here. So this is actually going to be fracture because those are smooth but random. They're not clean, flat breaks. So remember, it has to be smooth and flat. Number 3, this is clearly fracture. I think this is probably the most evidence of fracture. It's very random breaks. There's not a whole lot of distinction to it. And then number 4, this is cleavage. You can see the 90-degree angles. You can see the symmetry. You can see the flat breaks.
So that's going to be cleavage as well. So if you can determine whether a mineral has fracture or cleavage based on how it broke from its larger piece as a mineral, you can also, that will help you identify it. And we'll be keeping track, keep in mind, as we go through from mineral to mineral, what mineral has what, and then you can kind of compare. So last couple slides here. So the physical properties of minerals can be used to identify the mineral. So we've already said that, but there's actually other ones that we probably won't use too much in this class, but I want you to know about them. So we're not going to taste. I could get in trouble for letting you taste all the minerals, because then I would have all the students with tasting the minerals, and that would be unsanitary. But you could identify a halite because it would have a salty taste. Fluorescence, some fluorescent rock, minerals do. When you put a black light on them, they will glow. And I actually have some of these, but I need a black light, so maybe I'll try to get one. Some of them will fizzle like limestone when acid is placed on it. Some of them have optical properties, and actually we use them for their optical properties. So so they can actually like make things look double or closer or smaller. Some minerals are radioactive. Unfortunately, we don't have the right tools to figure that out. And then some are have magnetism. And we could do that, but we're probably not going to use magnetism. But these are some other ones that you might use if you were a geologist in the field. But we're going to stick to the main 5 that we already talked about. All right, so this is the major question. Once you have identified and listed all of the physical properties of an unknown mineral, where do you think you could go to find the information to match those properties to a known mineral? Question mark, question mark. What do you guys think? I might make this an Ed Puzzle question. But if you thought the internet, then you were correct. So it used to be, if I was running this class, I would have to print out a ton of different guides for you to use, and you'd have to look through them all. It'd basically be a giant textbook of all the different minerals and their fractures and hardness and cleavage and all that stuff. And there's so many different types of minerals out there that it would be very difficult. But you guys have Google, and that's going to make things way easier for you. So you can actually look up what certain fractures, you can actually look up the specific qualities of your mineral that you're looking for. And what'll happen is I'll give you what possible minerals they are, because this would take forever if I didn't. I would give you the possible minerals, and you would have to figure out, you'll have to match the mineral based on its physical properties, and so you'll do that using the internet. So most of the time you can look up these charts. So you could look up, let's say graphite was one of the minerals I gave you. Well, here's a chart I found online of all of the different things that it will have a black streak, it'll have a hardness of 1 to 2, it'll be metallic or submetallic, opaque, and all of that. So you can find this stuff online. I won't be providing it because we have iPads, so it's just easier to do it that way. And then we will be practicing these skills actually tomorrow, the day after you guys watch this Ed Puzzle video. So be prepared. All right, well, that's actually all I have for you today. I'm not sure what this video is at, but hopefully it's around 10 minutes. Okay, bye.